Okay. So here we go. Rate is a comparison between, that's between two values with different units. And I already talked about that, right? As an example, 204 words per minute or 20 kilometers and 3 hours, and the list goes on and on. So that's a rate. A unit rate is a rate in which the denominator is 1. So example, 240 words. Let's say you're writing 240 words in 8 minutes. This would be considered a rate. Okay, 2 different units. If you want to get it into a unit rate, we divide both of the numerator and denominator by the whatever is in the denominator. Okay, so 240 divided by 8 is 30. So you're basically reducing the fraction, right? You've done reduction of fractions in APR and a grade 9. And so 8 divided by 8 is just 1 minute, right? Or we can also write this as 30 words per minute, right? So you got to understand that it can be written like this, but most likely in a word problem, it's going to be written like that. So this is unit rate. So that's as easy as that. And so unit rates are very important, especially when it comes to comparing. You want to know how much in 1 minute can be done, or in 1 hour, or $1 gets you how much produce, right? Like, so you want to make sure you know that, right? So comparing rates. And this is also known as determine the best buy. It's not always about buying, but quite often. Okay, so a couple of pointers here. Just gonna underline that. The first one is units need to be the same. And I will put down convert as needed. And you want to find the unit rate. And state the better rate and by how much. Okay, let's do an example here. 12.8 kilogram turkey at Safeway for $42.89, or a turkey at Superstore for $1.49 a pound. And so just for note-taking purposes, I'm going to split them up in two columns, right? So I'm going to deal with Safeway here and Superstore on the other side. So you have a couple of choices here, and this is what you might find a little frustrating. Mr. Dirksen key shows it this way, but I did it this way. And the answer is, as long as you're consistent, you can there's at least two ways of doing this, right? But the key here is that the units need to be the same. So for example, you have kilograms and dollars, and then you have pounds and dollars. So you can't have that. They need to both be in pounds or both be in kilograms. So my first approach is going to be as follows. So I'm just going to write down, I take the dollar amount, $42.89, and say that that's how much I pay for 12.8 kilograms. Okay. So I will say this, when it comes to dollars, dollars always go to the top, right? When you have two different things and dollars are involved, put it at the top. So dollars, it's always cost over quantity, okay? So my goal is going to be to get this into dollars per pound, right? So this is a rate because we've got kilograms and dollars. So I'm going to say that, I'm going to multiply that by, I know that 1 kilogram has 2.2 pounds in it, right? And then I can cancel out the kilograms like that. And that will get me, if I multiply this out, I still have 42.89 over, and I multiply these two, and that's, I'm just gonna, it's 28.16 exactly. So I'm not losing any rounding, right? I'm not even gonna have to worry about rounding. So it's 28.16 pounds. Because remember, pounds are left in the denominator, dollars in the numerator. So this is a rate, okay? We're close because Superstore, I should have given myself more room here, right? Superstore is $1.49 per pound. This is already a unit rate, right? So I'm getting closer because I brought Safeway to dollars per pound, but I need it to be out of 1 pound before I can ultimately answer the question. Okay, so I'm going to go, let's just do one more line. And I'm going to divide both of them by 28.16. And so that gets me, I'm going to go 42.89 divided by 28.16. That's 1.52. See that? 1.52 over, this we know is 1 pound, right? So I can just put pound down. I don't have to go 1 pound. It's up to you. But now this is a unit rate. So now you have both of them in the same unit and they're both a unit rate. This is when you can make your conclusion. Which one is better? The bigger number. Right? You're buying stuff, so you want it for cheaper. So right here you pay $1.49 for a pound. Here's $1.42. So you will say this: Superstore is the Best Buy okay, comma buy. How much is it going to be? It's not that much to calculate, but you just quickly do a little, right? It's 3 cents, right? Per pound that you're saving. Sorry, I should have put that 0 there. $0.03 per pound. So this is your concluding statement to do that. Is there a different way of doing it? Dollars per kilogram, right? You could have done that way. So I will actually do it so you know how that is done. Or, right, I'm going to go 42.89 over 12.8 kilograms. That is now a rate. All I have to do is turn it into a unit rate. So I will divide both by 12.8. That's 3.35. And technically this still continues, right? The divide. And on the other side, I have 149 per pound. I will put down 1 pound like there because I'm going to do some calculations with it. They're both unit rates, correct? Can I compare them? No, right? Because one is kilogram, one is pound. So I have to do something with this guy because that's my game plan. So I'm just going to say that one kilogram has 2.2 pounds. The pounds go, right? I wish the pounds would just go like that. Wouldn't that be nice? Instead, I have to go on the treadmill. Right? What would I put down there? 2.8, right? I just want to say something. Sometimes the prices are so close that you have to go a third decimal. It doesn't happen very often, but sometimes you have to do that, okay? So in this case, I'm just going to round 3.28 dollars per kilogram. Now we can compare them, right? And still, as we expected, Superstore is better, right? Superstore is the best buy, okay, comma, buy. That's 7 cents per what? Kg. So you've still done the same thing. You've still proven that Superstore is the best buy. You just went a different route. Chances are that on a quiz, I'm kind of gonna force you to go one way because it's easier for me to mark. But you should be able to do both. All right. So both ways are acceptable. All right. Next page. Which is faster and by how much will be one of those. 14.2 meters per second or 50 kilometers per hour. So again, they're both unit rates, okay? So what you're going to do is, you're like, yeah, they're unit rates, I can just compare. It's like, no, you can't, because different units, right? So different units, right? So watch out for that. Okay, you got to work with that. So which one do you want to work with? It's up to you. I'm going to turn the meters per second to kilometers per hour. Just because, right, like if it's a bigger, then you don't have to worry with really small numbers. So I'm going to go 14.2 meters over 1 second. And I know that 1 hour, I gave you this one yesterday, right? 3,600 seconds. And I know I'm going off my script because I told you I usually tackle the top number first, right? Well, this is to show that it doesn't have to be, right? So seconds go with seconds. I'm good now. I'm going to have this out of, right, in hours. And then times, I'm going to go, I want to cancel the meters. So I'm going to go 1 kilometer is equal to 1,000 meters, right? This needs to be correct. But the placement matters. Cancel the meters like that. And then you basically go 14.2 times 3,600. This is kilometers, and this is hours, right? And then basically what you do now is you turn that into a unit rate. Basically just go top divided by bottom. That is really what you're doing when you're, so that's 51.12 kilometers per hour. So you have to say that 14.2 meters per second is faster, right? We go back to the original, comma, by, you can do this in your head, right? 1.12 kilometers. Don't just say 1.12 kilometers. It's kilometers for every hour that passes, right? You could have turned the 50 kilometers an hour to meters per second and then just compared the meters per second, right? But you don't make a decision until you have a unit rate. Here I had them both in the same units, but I didn't have it as a unit rate. Okay. All right. Okay. You try one. 20 meters per second or 30 miles per hour. Give that a go. Meters per second or miles per hour. So obviously some of you might have done it differently. So I'm going to take the seconds. And I'm going to 1 second, right? So we're going to take it to miles. First off, I'm going to go that 1 kilometer has 1,000 meters. That cancels here. And then knowing that 1 mile has 1.6093, right? Yeah. All right. So I'm taking care of the kilometers, sorry. I'm taking care of that. So we're in miles now, and I need to take it to hours. So 1 hour has 3,600 seconds. Seconds go with seconds. I have miles and I have hours. Okay. And let's see here. My key is different because I went off my key, off script. That's what happens. Saying 2,000 miles over. This will just shift the decimal 3 places. So, and now I'm going to divide it. 44.74 miles per hour. So 20 meters per second is faster by 14.74 miles per hour. If you went the other way, if you converted 30 miles per hour, it's 13.41 meters per second. So either way is fine. Okay. Okay. We're good. Let's switch gears a bit. I'm going to start a new page. So if you're about halfway through, I'm going to start a new one. So this is touching a little bit more on 8.2, section 8.2. Solving problems involving rates. When you are given a rate, comma, you will often be asked to solve for a scenario where the rate is extrapolated. What is he talking about? You remember in extrapolating when you go above beyond the graph? Do you remember that? When you're going like you know something is true. Remember rise and run? You could use that slope to predict a point way out far away from the line you just graphed, right? So the same thing is going to happen here. So example, I just like examples to make my point here. So let's say 2 cans of paint cover 315 square feet of wall surface, right? So this is the rate that you're given. Right? Comma. How many cans are needed to paint let's say 900 square feet. So rate, and this is extrapolation. Stop using those fancy words, Mr. Durson. Well, it's just a rate, and this is a scenario. If one of these is true, what would be true about the other item in this list, right? Because there's two different units that are compared, and you're given one of them, which is square footage. It's in the bottom here. So what would the top have to be for that rate to stay true, right? So that's when I want you to set up a proportion. set up a proportion, then cross multiply and divide. So these types of questions, and you will have seen one of them already on the key if you did your homework. So maybe after today you'll have a better grasp. Okay. So for example, you say that 2 cans cover 315 square feet of surface, right? So you will ask yourself, how many cans will be required to cover a surface of 900 square feet? Right? This is a proportion. Fraction is equal to a fraction. Match units in numerator and denominator. Okay, it's very important that you match cans with cans, square feet with square feet. Right? If I'd given you square meters, you're out of luck here, right? Like you can't compare square feet to square meters. We'd have to do some conversion there. So in this case, I'm going to show you a trick here. You cannot reveal that I'm the one that showed you this trick. You might already know the trick, right? But I always want you to focus on where's the variable. And that's where your journey starts. In this case, if the equal sign is in the middle, we start on the right side, right here. And then you cross multiply and you divide. Okay, so you cross multiply and you divide. You don't need to show this step when you do your work, but that's what's happening. So x in this case will be found by taking 900 square feet, multiplying it by 2 cans, dividing it by 315 square feet. Now you won't have to do the units. I'm not too picky with that, as long as you show me the numbers that you're multiplying and you're dividing. But watch what's happening here. The square feet actually cancel out with the square feet. So what are you left with? Cans, right? Which is what we want anyways. So you go ahead and calculate that. 2 times 900 is 1800, right? Divided by 315. 5.71 cans. Watch what I'm going to do here. I understand that this is a scenario where I need a whole number. It's called discrete data, right? So I need to go, I write down my answer and that it keeps going. How many cans should you be buying? 6 cans. That's right. Try to go to Home Depot and tell them you want 5.71 cans, right? It's not going to happen. Right? So there it is. So you have some left over, of course, but this is how you would calculate that. So you were given a rate, you were given either this, they could have given you the number of cans, and then it would ask how much could you cover with that many cans, right? So that's how you do these ones. Let me see here on the back side. Okay, here we go. So we're going to kind of mash it up a little bit here. Okay. If a car has a fuel economy of 9.5 liters per 100 kilometers, sorry, it says 9.5 liters per 100 kilometers. I hope you can see that. Okay. How many liters how many liters would you need to travel 1,245.8 kilometers. And so fuel economy, maybe you're not quite familiar with it, but that's usually how it's stated in Canada. It's like how many liters that car uses to drive 100 kilometers, and that's an average. It uses more or less depending on the terrain and depending on the crosswind and all of that, right? But we know that this is a rate, okay? So this is a rate given to you, and it's an extrapolation scenario, okay? So set up your proportion. I suggest you start with the proportion, right? They could have given you a unit rate. Instead, they just gave you a rate. And so you will just say, hey, if that is true, then on the other side, right? Oh, I should have, anyways. I was just thinking of adding a curveball to this, but we'll leave it at that for now. So you match your kilometers, and then you're going to figure out X number of liters, okay? And you will figure that out, right? You cross multiply and you divide. So it's 1245.8 times 9.5 divided by 100. It's 118.35 liters. Can you do 35? Yeah, you can get, especially fuel, right? You go to the pump, you can get whatever you want. It's going to be difficult to stop it right at that, but you can, with volume, it's okay to cut it like this in this case. Let's do a B part. How many miles could you travel on 80 liters? Did you say miles, Mr. Erickson? Yep. What? Take one step at a time, right? So this rate is always true. It hasn't changed, right? The 9.5. So I will figure out how many kilometers I can travel first. So 9.5 liters, that's what it takes to travel 100 kilometers. If I am given 80 liters, then I want to find out, right? X represents the number of kilometers that I will be able to travel at that rate, given that I have 80 liters. So again, your journey starts on the right side. In this case, cross multiply down, divide up. It's always multiply then divide, okay? So X is going to be 80 times 100 divided by 9.5. And that's 842 point. Watch this. I'm not done answering yet. So this is a new concept. I'm going to use at least 4 decimals, right? I rounded it to 4 decimals because this answer is in kilometers. I want it in miles, right? Times, I know that 1 mile, so we're meshing proportional reasoning with conversion together. Okay, 1 mile has 1.6093. Did I get that right? Yeah, kilometers. Another cool one to have is that 1 mile has 1,609.3 meters, right? If you want to just have that as well. Kilometers, kilometers. So 842.1053. It's basically divided by 1.6093. Sorry, there it is, right? I divided it. So that is 523.27 miles. That is the final answer. This answers the question. Okay? So what did we do here, right? And your answer, notice that your answer is not a rate. Your answer is just a distance, right? So we started with our rate to figure out, because they gave us one of the components, so we figured out the other one, in this case the distance traveled. We then converted it to miles, right? And that was that. One more. Am I too fast? Sometimes I'm guilty of it. Too bad you can't just slow me down, right? Like YouTube. Well, you will be able to after. We're good? All right. Right. Last example, right? Squirrel actually did my research on this one. Just 1 second here. For it to be accurate, okay? The squirrel can run 20 miles per hour, comma, while a pig can run 285 meters in 65 seconds. So just some facts there, right? So we're going to make this into an A and B question. A, who is faster? Right? And by how much? Let's agree that we're going to go meters per second. Right? My key is actually different, but I'm just going to prompt you. So like, I want your answer to be in meters per second. That way it's no doubting, like, what am I supposed to do here? B, how long in minutes would it take for the squirrel to run 152 meters? We could have gone both miles per hour. We could have done both kilometers per hour. You can actually do whatever you want in a normal scenario, but I'm prompting you to do that, right? So I'm going to answer A here. I'm going to take my miles per hour. Oh, sorry. Right now that I want to work with it, I got to go 20 miles in 1 hour, right? Like that. And I'm going to deal with the miles first. I know that 1 mile is it 9? 9, yeah. Can you handle this? I went, you know how 1 mile is 1.6093 kilometers? If you just multiply that by 1,000, because 1 kilometer, right, has 1,000 meters, I've just gone straight to there. So if you want to add that to your conversion rates, that's probably a good one. So that allows me to just do this. It's fewer calculations, right? And I want 1 hour. I want this in seconds. So there's that. So the hours go here. If you don't have this, big deal. You just go 1 kilometer is 1,000 meters, right? Like you just add that step, it will be the same thing. And so let's go ahead and go 20 times. I get this many meters over 3,600 seconds. And so that's 8.94 meters per second. Now this is a unit rate. I should have emphasized, right? This is the squirrel that I'm talking about. Right, so this whole line here deals with the speed of the squirrel. Pig is going to be here, and I'm just going to go 285 meters in 65 seconds. It's almost there. It's almost there. No conversion needed there. All I need to do is divide both of them by 65, right? And so that's 4.38 meters per second. Okay, so you have them both as unit rates, right? Unit rate, unit rate. So when comparing, you need to make sure they're both unit rates, right? I will do a little bit of math here on the side. I will subtract the 2 just so I have the difference, right? So this is 6. 8 minus 3 is 5. 4. There you go. Use your calculator. Right, there's no meters per second. So that's the difference in speed that I'm going to note. So I will say that the squirrel is faster by 4.56 meters per second. Would have been a nice one to say, hey, now show by converting both of them to miles per hour, right? That would have been a good extension. Just can't do it all. Right? Gotta call it quits at one point. Okay, grand finale here, and then I'll give you the homework, and then it's almost quitting time anyways. B is asking us how long in minutes would it take for the squirrel to run a certain distance. So this is almost like extrapolating, right? Like you're going to use a rate to answer that question. It's not asking for a rate in and of itself. So we're talking squirrel. So I'm going to go and get the squirrels, right? So it's 8.94 meters in 1 second. Question, Mr. Dirksen? Yep. Could I have used this one? Could I have used this one here? Yeah, because this is equal to that, right? They are equal. In fact, this one probably be a bit more accurate because we round it here. So that's just for another day. And so they're telling us that we're now running 152 meters. I make a note that the 152 is already in meters, so it matches the distance on the other side. If they had given me yards, I had to do a little bit more work. Right, so this is seconds. I just quickly go cross multiply and divide, right? So it's 152 times 1. Not really necessary, but it's still technically what's happening. It's 17. What happened there? Oh yeah, I didn't think this through. 17.00. We cannot really answer this in minutes, right? It wouldn't make sense. Yeah, we're just gonna say don't worry about this part. It's 17 seconds. I changed the speed of the squirrel because I did some research and it's actually faster than what I had before. So I should have increased my distance, right? We'll figure it out. Okay. Homework. I would say page 2 of the worksheet. You don't have a textbook. I was almost going to assign from the textbook. And page 1 and 2 in the booklet. That is a lot, Mr. Dirksen. Well, I said that and I will say it again. Let me just stop it here.